everybody. My name is Patrick, and I'm here to talk to you about connecting your smart contracts to off-chain data, APIs, and traditional payments with Chainlink. So before I jump into anything, I just want to say that right now we're really on the doorstep of this fourth industrial revolution. We're really on the doorstep of having smart contracts and blockchain adoption, explode. We've seen recently DeFi have this massive explosion with a ton of protocols jumping on, and we'll talk a little bit more about that in a little bit, but we're really at a point where people are starting to understand how to use it, how to use blockchain, the value that cryptocurrencies and smart contracts have, and it's starting to come aboard. So these hackathons are stomping grounds for innovation, right? We've seen a number of projects come out of these and a number of engineers come out of these and go to mainnet, go full-time, their project being what they do day in and day out. So this is really where it all starts, is these hackathons and showing up and joining the community. So, and it's going to be up to us to kind of push it. And we have this amazing opportunity in front of us because there's so many protocols that haven't been built yet, so many protocols that the blockchain and smart contract space is literally thirsting for people to build more things and get involved more. So really excited to be here, really excited to be talking about some of the potential that we all have here. And let's get right into it. So let's talk about Chainlink, the problem that it solves, how it solves it, where Chainlink is now, some untapped potential, and some of the tools you can use to become a part of history. So if we have time, we'll do a remix demo. So I know Harmony is EVM compatible. There's a couple of tweaks that need to be made, but doing everything in Remix is totally fine, and I've seen it in the documentation. So stay tuned for notes on how to do it a little bit easier with you not having to jump into the code. But let's jump into it. So in order to really understand Chainlink, we need to first understand that smart contracts are not able to connect to external data or any off-chain resource on their own. And this is a huge limiting factor for smart contract adoption because it means the only thing we can really do right now is token transfers. Now the question then becomes why can't blockchain just make an API call? That's what I do in Python. That's what I do in Node.js. What's the deal? What's going on? And this is a great question. And the answer is because blockchains are deterministic systems. This means that if we were to replay the blockchain from the Genesis block at block 0 all the way to where we currently are, it should end up in the exact same state every single time, no matter what. If we add API calls into this consensus protocol, we're going to get nodes that do not agree with each other at all, right? If a node calls an API, it says, hey, the API said Ethereum is $200, then another node calls it even a half second later, there's a potential for it to get wildly different results. And now these nodes are out of sync, and nobody can agree upon what the state of the blockchain really is. So this is really important that blockchains have this to stay deterministic, and it's part of what makes them so powerful. So then the question is, okay, well, great. How do we get data on the blockchain then? How do we get data into our smart contracts? Because we need to do these digital agreements. We need to have these to, come into the fourth industrial revolution. So this is where oracles come in. To interact with the outside world, we need to use what's called an oracle. An oracle is any device that interacts with the off-chain world to provide data to smart contracts. They report this result of that data on-chain so the blockchain can stay deterministic. So they make an external transaction, post it on-chain in that transaction, and that's how the data gets on-chain so it can stay deterministic. And this is really important. And this is where Chainlink actually comes in. So there are thousands of APIs, thousands of data sets. The world and the web is fueled by data, fueled by these APIs right now. This is what's powering all these applications. So Chainlink makes it really easy to enable connectivity between those APIs, between those data sets and smart contracts, even if they require authentication, even if they require additional computation, or really any type of gates that are there for these data sets, so that we can have decentralized applications powered by the same reliable APIs that the rest of the world and current web applications use today. In addition, a lot of users still don't understand blockchain. So sending payments in these cryptocurrencies isn't universally accepted yet. Chainlink also makes it really easy to send payments based off of these smart contract executions in the currency that the user actually needs or wants. So Chainlink not only is a way to get data, but it's a way to send data or interact with the outside world as well, such as doing tasks, paying people out, even some parts as simple as sleeping or waiting for a little bit, like a sleep function to do a timed lottery or something like that. Chainlink makes doing all these processes that would be really expensive on chain and cost a lot of gas. It allows for this customizable functionality to happen off chain. And it does this through this tool called an external adapter or an external task. Now, these are customized functional pieces of Chainlink. Anybody can update them. Anybody can write them. You don't need to write them in Solidity because you can write them in any language that you like and hook them up to your Chainlink node. And this is fantastic because you don't even have to be a Solidity expert. You don't even have to be a blockchain expert to get involved in the space and start building external adapters. We have a number of fantastic tutorials on this. If you do a quick Google on external adapter or build an external adapter Chainlink, you'll definitely get to the right place. Now, here's where I get a little bit more serious, and this part is really important. So a centralized oracle becomes a single point of failure for an entire smart contract. This is a big issue, right? The reason that we're building these smart contracts, we're building these decentralized infrastructures, these decentralized applications, or again, dApps, is to have them be decentralized so that we don't have to rely on these entities. We don't have to have this trust. We can have what's called these trustless agreements. If we build a smart contract and then our data set is coming from a single point, it's coming from a single oracle, guess what? If that data set gets hacked, if that data set gets hijacked, if it goes down, if they get bribed, they start being malicious, the smart contract is now ruined, right? And even if it doesn't, we're relying on this data set to continue to be honest, to continue to be truthful. So we have this trusted point that they can ruin everything that we do. So we never want to build a production application relying on a single centralized oracle because now they have control over the smart contract and your application is no longer decentralized, right? It kind of defeats the whole purpose. You're doing all this work to build this really powerful, awesome blockchain application, and then you put a centralized oracle on it, and it just automatically it sucks out any decentrality that you went to great lengths to probably get. So we never want to have a single centralized point of failure. So, and a quick note here too is saying, a single Chainlink node itself is decentralized is a lot like calling a tree a forest. One single Chainlink node, one single entity doesn't make up the whole. To make these applications truly decentralized, you need a network of Chainlink oracles. You need a network of Chainlink nodes so that they stay, reliable and secure. And there's a big reason that I'm really stressing this. Not only because it's really important, but we've already seen attacks that projects have lost projects and literally millions of dollars since their centralized oracle was hijacked. You've probably seen in the news, flash loan attack, somebody did a flash loan and attacked the protocol. Usually how the flash loan attacks work is somebody crashes whatever oracle, whatever service that a protocol is using, flash crashes it using flash loans. The price of that oracle then spits out something really random, and whatever protocol was using that price now has wonky prices, and the whole smart contract gets wrecked. So people say, oh, it's a flash loan attack. They're really pricing oracle attacks, and if they use decentralized oracles, they get protected from this because if somebody hacks and flash crashes this one protocol, doesn't matter. Similar to the blockchain, if somebody destroys a single Ethereum node, nobody cares because there are so many more nodes allowing for Ethereum to be decentralized or Harmony to be decentralized. It's the same thing. So Chainlink is designed to be this modular infrastructure and can build a decentralized Oracle network used to connect smart contracts to any API. You can select as many Oracle nodes or, again, Chainlink nodes as you like and use as many data sources as you like in order to trigger the execution of your smart contract. And then again, Chainlink allows these external adapters to make them even more customizable to do these more interesting things off-chain if we want. Chainlink also has what's called external initiators, which allow it to be blockchain agnostic, work with any chain, be it Ethereum, Harmony, Avalanche. Those are some of the EVM compatible ones, to even some of the non-EVM compatible ones like Conflux, Polkadot, etc. So to get started with DeFi, the Chainlink project has actually gone ahead and found many of the best blockchain node operators on the planet, combine their prowess to build what's called price feeds. These are decentralized on-chain price points that can be considered source of truth for the various currency pairs, like the price of Ethereum in terms of USD, for example. And here's a visualization of that. We can see in the middle is the price of that pair. In this case, it's Ethereum USD. It looks like it's from a couple of months ago, actually, this image here. But we can see around the node, around the price in the middle is the network of Chainlink oracles, each independently and individually gathering data, reporting it on-chain, and you can see all this on-chain. You check out feeds.chain.link. You can see this visualization and everything here. But you can see everything that they report. It all gets aggregated on-chain to give this answer. And again, if these nodes get attacked, it doesn't matter because of the decentrality of the system. So, and the other fantastic thing is this is kind of the next level on Chainlink's core functionality, which is kind of this singular, get, request, and receive architecture. And if you want to build your own price feed, you absolutely can. If you want to build your own data feed for weather data or your own decentralized feed off of Google, something in Google's BigQuery or whatever you want to make, you absolutely can make it and make it decentralized and use any nodes that you wish. So currently, these price feeds are already being used by a ton of top DeFi projects around the world. The proven safety, reliability, and power of these protocols is a testament to the power of these Chainlink these Chainlink price feeds. So we can see it's across a ton of different facets of DeFi: synthetic assets, lending and borrowing, trading, asset management, and it's really a testament to how powerful these price feeds are. So this is an image of DeFi Pulse from, I think, a month or two ago with some of the top projects. If you haven't checked out DeFi Pulse, definitely give it a look. It shows the total locked-in value of these different DeFi protocols. And about a month ago, Aave was at the top with 1.5 billion. So that's $1.5 billion locked in. Curve.finance, Maker, Synthetics, Yearn.finance. These are all incredibly powerful protocols being powered by DeFi, this decentralized finance. And 3 of these top 5 are using Chainlink price feeds, Aave, Synthetics, and Yearn.finance. And you can see 1.5 billion, 800 million, 800 million. They're locked, they're securing a lot of money. And this just goes to prove how powerful these Chainlink price feeds actually are. Because if they were hacked or if they were attacked, there's a lot of money on the line here. So we're proving how powerful they actually are. So, and again, it's supporting the growth of DeFi, Synthetics, Loopring, Set Protocol, Aave. There's a ton of Chainlink-powered DeFi projects right now, and that's one of the most popular smart contracts in the space is DeFi. And a lot of them are using Chainlink price feeds because, like I said, it's this very reliable, powerful, almost you can think of it as a definitive source of truth for these price feeds. In addition, getting random numbers on chain or for any computer system has kind of historically been an issue, right? If you've ever looked deep into computer science, computers are deterministic creatures by nature, and getting a random number is usually secretly a pseudo-random number. Now, this is fine for your own kind of home application or your own server, but on a blockchain where everything's decentralized and everything is, not owned by a central entity, this becomes an even bigger issue because the entire blockchain is decentralized. The entire blockchain is deterministic. So if you can determine what the random number is, it is no longer deterministic and you can ruin any fairness. Like imagine having a lottery and there were some people who maybe they didn't quite know exactly what the lottery number that you were going to pick was, but they could reduce they could reduce the numbers that it isn't by half or something like that, right? So getting random numbers on chain is kind of like that. It's not so easy, and it can actually ruin a fair application by trying to get a random number without using something like Chainlink VRF. So Chainlink VRF makes it gives us a way to get a provably random number, which is kind of an insane feature. Excuse me there. Which is an insane feature because now we can have these truly fair, provably random lotteries. We can have these truly fair, provably random, sampling for medical services. We can have, random stats for games. It really just opens this new chapter for people to build smart contracts and have reliably random applications. And that's we're seeing more and more adoption here. We're seeing more and more projects get spun up with the Chainlink VRF. Definitely go check out the docs on that too, docs.chain.link. Everything's there, and you can start building today. You can start building today with all of these, actually. You can start building months ago, year ago. Anyways, so this brings me to our next point. So there's a blog out there. It's called 44 Ideas to Power Your Smart Contract. I highly recommend checking it out if you're kind of looking for ideas for the hackathon here. And like I said, the blockchain space is really thirsting for Chainlink applications and really, really looking forward to people coming into the space and unveiling some of this untapped potential. So here's just a couple of them right here. Decentralized finance, like I said, right now it's massive, but it's not even close to hitting the total market cap of traditional finance. So Chainlink is kind of is helping secure billions of dollars right now. And it definitely can help with further DeFi protocols, and we're seeing more and more projects come to us looking for help too. So gaming and sports in general, decentralized gaming is huge. Like getting these random numbers, having these random numbers for the gaming and the NFT world is massive because then you can do these games and they're actually random instead of pseudo-random. So nobody can cheat and nobody can screw anybody over. And the upside on these is actually much higher because you're doing it on chain and you can have, you don't have the overhead of a regular tournament, which is really exciting here. So tokenized assets is huge. Splitting up your car, plots of land, shares of stock, making it really easy to track who owns what without having to deal with any paperwork. And since all your data is coming from these decentralized oracles, nobody can mess you up. And the final one here is an insurance example. This one I think is probably one of the most interesting and probably one of the most important ones, and really hits home for me. But let's say for example your crops are all messed up due to the weather, right? And your insurance doesn't want to pay out because of some pre-existing condition. With a decentralized smart contract, you don't have to trust that the insurance company is going to do the right thing, since the right thing is infrastructural with Chainlink. So, with that being said, like I said, everything that you need to know is in the Chainlink documentation, and I'm zoomed in almost a little too much here. But everything you need to know is here. So if you want to use price feeds, you can come check out the price feeds. All the integrations are being done here. Harmony to be added soon. I'm not sure when. I'm not on that, but stay tuned. Stay tuned for the notes. But yeah, if you want to come here, you can literally get the latest price. All the code that you need is right here, and it even gives you a remix button to flip over to remix so you can see it in a UI. So this is I believe this is the Coven interface. So I'm just going to make sure I'm on Coven. I forget what my test password is. Okay, that's my test password. Great. And it'll spin up everything in here for you, so you can just compile and deploy. And for Harmony, what you would do is you would just flip over to your Harmony network here. But we're going to deploy a smart contract. And the smart contract is going to get us the price feed. It's going to get us the latest price of ETH USD. And again, it's coming from this contract right here on the Ethereum chain. So this is what a price feed looks like when it's all put together. It's really just a simple view function. It's super easy to work with. And now you have a decentralized piece of truth here. So, whoops. Do I really want to leave the site? Yes, I do. So the other bit, so randomness, the VRF stuff is here. If you want to look into, a little bit more of the architecture, you can go here. You can learn how to deploy with Truffle, deploy with Hardhat, all the tools that you're familiar with. But I do want to show you this one as well, making a GET request. This is you making any API call, on chain. And again, if somebody's feeling really ambitious, GitHub Chainlink, this would be an insane project right now. All the Chainlink code is open source. So if you're familiar with like Goeth or Geth or JSON RPC calls or how to do any of that, the Harmony chain is EVM compatible with a slight tweak. There's only a couple things to tweak to actually make this integration work. I think a stellar project would be to mix these two yourself. I think that would be, really, really impressive. And so I challenge anybody who's looking for a challenge to do that, because the new version of Harmony is a little bit different than Geth. So you would have to make an external initiator. But in any case, once you do that, here's what it looks like basically. We have our code here. Again, we're on Coven. We have our API consumer Chainlink. We have a couple of, one public variable here. And let's just look at the request function. Hopefully you guys can see this. I think you guys can see this okay. Let's close this. Yeah, hopefully you guys can see that okay. So we have this request volume data function, right? And so it returns a bytes 32. It's going to return the ID of the Chainlink request. So we're going to build this Chainlink.request object in memory, and it calls this build Chainlink request, which we get from importing the Chainlink client and inheriting it in our contract. But we build this Chainlink request and we send it the job ID, the address of the that we want to return the data to, and the fulfillment function. So this, and again, this is the core functionality that's powering the price feeds and allows you to get any data that you want in a decentralized fashion. So when you make the request, it actually it emits it to the logs here. The Chainlink nodes are looking for it, again, on any chain out there. It looks for it, it reads the log, it grabs the request, it does whatever it needs to do. We'll go into how we actually define the parameters of the request. But then it returns it in this fulfill function. And again, you can define your fulfill function here. You can make it do whatever you want, and then it fulfills it below here. And it returns a request ID and the data that you want. So something important to note is when you're choosing a job and an oracle, you have to choose a job that has the correct return type. And I will talk about that in a second. But when you send the request, simple as just doing request.add a get request or a get task. And here's the API that we're going to do. Here's the path. When we call this API, we get this JSON object back like this. We get this JSON object back, and we only want, what do we want here? Volume 24 hour. So we're going to walk this path, raw, FUSD, volume 24 hour, and we're going to look for this number here. So we're looking for the volume for the past 24 hours here, and we add that right here. We say, hey, we're going to walk this path because, again, gas is the thing. We don't want to put the whole JSON object on chain. Then we do this multiply as well because blockchains don't work with decimals so well. So we're multiplying it by this amount, and we add that again as another adapter or task, and then we send the Chainlink request to the oracle, with the request for the fee. So then what I was saying before, we have to choose the job ID and the oracle, because again, each one of these nodes is independent of each other. So we're actually choosing independent nodes, and We can go to a node listing service to choose those nodes for us, or to find the nodes. We're on the Coven network. Market.link is probably the most popular node listing service at the moment. We can look for a get uint 256, and we can see there's all these nodes that are get uint 256, and we can grab make it so. Oh, that's kind of funny. We can grab the node or the job details. So get uint 256. We have the job ID right here, and then we could grab the Oracle address here, and we would just prop that in to here, Oracle address and job ID. So I'm not going to do it now because I haven't worked with that node and I don't know yet. But again, all these nodes are independent nodes of each other. So if we go back here, we can scroll down. We can see a whole bunch of different metrics, new feeds, new nodes, explore nodes. We can see all these nodes, right? And these are all independent nodes. And you can see, there's a ton for all these different networks. I'm sure they're going to add multi-chain soon. But in any case, we're going to compile. And yeah, if you build one on Harmony, definitely ping them and say, hey, I got a Harmony one. Can we list me? I think that would be you'd be one of the if not first Harmony chains on their marketplace. So we're going to compile, and we're going to deploy it to injected Web3. Confirm. Again, we're on the Coven network here, so things should be pretty quick. And great. And now I'm going to call this, but it's going to fail. And I'll tell you why in a second. It's going to give this gas estimation failed. So similar to making transactions on chain, you have to pay a little bit of gas. When working with oracles, you have to pay a little bit of oracle gas. So we're going to send it some link, sending it to probably a little bit overkill, but just in case I want to test it a couple times. We're sending this contract to link, and what's going to happen is it's actually going to send the Chainlink node the link that we specify in this contract. So we actually define the fee here as 0.1 link. So we're giving it 0.1 link with this request. So now we can hit this request volume, and it actually works this time. And before it returns, the volume will be 0. What's happening now, as this transaction goes through, once it goes through, the Chainlink node will pick up the request. It will grab this API that we gave it, this API call that we gave it. It will make the API call, and then it will return it on chain with this fulfill function. And again, everything that you want to do is in the documentation here. It's really as easy as clicking this this big remix deploy button and playing with it yourself. So hopefully that's done. Yep, and it looks like it is. And it returns the data right here. Again, this volume is just a view function, so we can just click it and it'll show us what's going on. We can hit this view function. We can see what the response of that API call is, and we can get the data on chain. So I guess I have 2 minutes left here to also show the VRF. Yeah, let's show the VRF too. So yeah, the VRF is the same thing. We're going to make a random API call. And again, you can read more about what it's actually doing in here. Random number.sol. We're going to compile it. I hit Command S, which compiles it as well. There's a couple of additional parameters we got to do for the VRF, like the VRF coordinator, the key hash, the user provided seed, and you can read more about why that's important later. But yeah, we'll compile it, and then actually let's get a random number. I think I do mod 5, right? That should give us a random number between 0 and 4. I think that's right. Well, let's get a random number between 0 and 4. So we compiled it. Let's deploy it now. Injected Web3. And great. And again, we're on the Coven for this too. We follow the request and receive cycle here. So we're going to send this to Link as well, just to be safe. And once this finishes, we're going to request a random get random number. We do have to give it a user provided seed. You can read a little bit more about that and why you need it in the documentation. But that's basically going to help prove that our number is actually random. So it looks like it went through. Let's do 1, 2, 3 for our user provided seed. Oh, maybe it didn't go through yet. Maybe we'll give it a second, and we can see right now the random result is nothing. Looks like it still didn't go through. Well, this is a test net, so stuff doesn't always work exactly as we want. Let's try again. Yeah, test nets don't always work exactly the way we want them, but yeah, let's just give this another try here. Looks like that's confirmed. Let's try this now, and yeah, it's working now. Maybe it was just a little bit late. I know my MetaMask is a little bit over. Let me shorten this a little bit too. We're going to confirm this. Confirm. And again, right now what's happening is it's made this, we've made this get call. We've posted some data to the Ethereum log. We're waiting for the VRF coordinator and the Chainlink node to grab it, generate us a random number, and post it on chain. And again, the VRF coordinator, you can check out the contracts that use that and figure out, look into exactly what it's doing if you want. But that's what's helping verify that the numbers that we're getting are truly random. So I did it right. So we got 4, which is a random number. So I know we went through a lot here, and there is a lot to cover. There's really so much that we can do in the smart contract world, and we can build some awesome applications. So really looking forward to seeing what people build here. Layer 2 solutions are fantastic, and you're really helping with scalability. So really excited to see what everybody builds. If you have any questions, feel free to jump into the Chainlink Discord, ask any questions. We're super active in there. And we're posting Stack Overflow, Reddit, wherever you want to go. Discord's kind of where most of the community is right now. But really excited to see whatever everybody builds. Best of luck, and I'll talk to you soon. Thanks.